Hello, everyone, and welcome to episode number 2 of this free course. We are calling this course Learn Penetration Testing and Level Up Your Career from Beginner to Pro. This episode 2 is a two-part tutorial. In the first part, we will look into some theory, and the second part consists of lab and live demonstration. So, today, our topic of discussion will be stack-based buffer overflow vulnerabilities in 32-bit machines, or just simple buffer overflow. If you happen to watch episode 1, where we covered all the basics about this program, we discussed our route of training to be almost 100% hands-on practical. But let me start this first part with few important terminologies and concepts, and in part 2 we will continue on towards live demonstration. So today we are going to cover introduction to buffer overflow. A few concepts about it. I will try to keep it under 3 minutes only. If less, the more better. Environments affected by buffer overflow and its history. Alright, in the beginning of this episode, I mentioned 32-bit machines. So in the year 2021, where every computer or CPU is relying upon 64-bit technology. So the question pops up, is it really relevant in 2021? We will try to cover it as much as possible under 2 minutes. And finally, we are going to get our hands on writing a buffer overflow exploit and how to use it on a real life 32-bit machine. So let's talk about memory layout first. At the top, there is kernel, the core of any program. At the bottom, there is text, a read-only segment in which a machine language instruction is stored. In the top middle, there is a stack, an area devoted to store all the data needed by a program to run, and that's what we are interested in. Now, if you dive in further, you will see the stack is composed of other allocations. On the top, there is ESP, or extended stack pointer, and at the bottom there's EBP, extended base pointer. While in the middle, we have buffer space to store all the data, and after the process finishes, it returns the address back to the routine's caller. It might sound a bit confusing right now, but it will get better in the next video when we will start putting things in perspective during our lab. Okay, try to understand this way. Buffer space is allocated to store all information, and a buffer overflow occurs when a process attempts to store data beyond the limit of a fixed size buffer. And it happens due to a programming error and overrides adjacent memory locations. It may corrupt the data, or crash the program, or may cause the execution of malicious code. In other words, you are allowed to put only 8 bytes of data into the buffer space, but somehow you manage to insert additional 2 bytes. That subsequently led to overflow the data to the next memory location, hence changing the sole purpose of a program, or intentionally you have done it to gain control over the machine. Now, moving on to topic number 2, environments affected by buffer overflow and the history. A quick research tells you that assembly, C language, and C++ are the most vulnerable languages so far, whereas languages that are strongly typed and do not allow direct memory access, such as COBOL, Java, Python, Ruby, etc., prevent buffer overflow in most cases. Buffer overflow were first documented as early as 1972, when the Computer Science Technology Planning Study pointed out that the program executed does not check the source and destination addresses properly, and it allows the user to overpopulate the kernel beyond its allocated memory size, which may permit the user to take control of the machine eventually. And in the year 1988, Morris Worm struck the internet first, followed by Code Red Worm in 2001, targeting Microsoft's Internet Information Services IIS 5.0, and SQL Slammer in 2003. So that was just some basic information, and I can keep going on and on for a whole day, but it's gonna be boring. So let's move on to the next part. Are buffer overflows is still relevant in 2021? Absolutely yes. They might not be the biggest threat after latest technology such as DEP, ASLR, but they're still worth learning. According to OWASP, buffer overflow is probably the best known form of software security vulnerability. Most software developers know what a buffer overflow vulnerability is, but these attacks against both legacy and newly developed applications are still quite common. This whole procedure tells you how things actually work, how they utilize the pieces of hardware to complete those operations, and honestly, for some of us, it's really, really important to understand all of it, just in case that we want to break things up just for the fun of it, because that's what we do. So, to get into every other thing, to do a research and help patching things up, it's part of the job. So, before anyone else would try to get into our network, we could fix it beforehand. Because you might have learned in your school that there is a good knowledge and there is a bad knowledge, but in this field of science there is no such thing as bad knowledge. Every piece of information that you will find on the internet is valuable. Even I say learning about a 5-inch floppy disk will lead you to somewhere important where you can relate the modern information to enhance your skills. So here's a small exercise for you. Perform a Google search, buffer overflow attacks 2021, and let me know your thoughts on how much do you think buffer overflow is relevant in 2021. All right, this is the end of our theory session. I hope I have explained things better. So let's move on to the lab in the next video and have a look what buffer overflow really does.